Hello everybody, and a very warm welcome to this introduction and overview session of the certificate program in Python for algorithmic trading. Really excited to get started today with the first cohort in 2019. We, as usual, I can say, have a few new things added to the already quite comprehensive program with a focus on Python, but of course we cover a lot when it comes to algorithmic trading there as well. I've prepared this slide deck, which contains, let's say, the major topics that we want to cover today, but it's not the only resource. I will also go into a few case studies and demos, so some of them live, some of them based on prepared Jupyter notebooks. So we cover quite a bit of ground already, and you should get a good overview and a good feel of what to expect from this intensive 16-week program, where we have some 12 weeks of formal structure and 4 weeks of practice modules. Let me dive into my slide deck and get started. Here is the agenda. The introduction is a little bit about our company, also a bit about myself. And then we are going to give a broad overview of the program itself and go through the single major classes that we have there, like Finance with Python, Tools and Skills, Python for Financial Data Science, Python for Excel, for databases, Artificial Intelligence and Finance, which is a completely new class. And the core class is the Python for Algorithmic Trading one. I then show how to work with the study plan and what the single elements mean. And based on that, we're also going to cover the case studies and demos that I mentioned before. And I'm going to conclude with a few arguments supporting the importance of practice. Let me dive into the slides themselves. A bit of an introduction. I myself am Yves. I'm founder and managing partner of the Python Quants, and we at the Python Quants, we do quite a few things, but they have all basically the same core, namely the application of Python to financial disciplines, and more these days, also Python in combination with AI algorithms in finance. Around these major topics, we provide services for financial institutions basically on a global basis. We provide offline as well as online trainings. We run the platform, which I will demo later on, where we have close to 20,000 registered users. We've open sourced quite a few Python packages. I've written 3 books on the topic, and we also run events in the form of meetup events or boot camps, like the For Python Quants bootcamp. Mostly we're active there in the financial capitals, like in London and New York, or also in Germany, Frankfurt, in Europe, also in Paris, for example. So quite a few things. If you want to learn a bit more about us, please visit tpq.io. From there you find links to other resources. One of the major elements of the program is the Quant platform. On the Quant platform, we provide basically all the materials for the program. This means, for example, recorded sessions in the form of videos, but also codes and text resources. You can there not only access the resources, you can also execute codes. For example, do your interactive analytics, train yourself, work on your projects. It's a full-fledged web-based interactive analytics environment, and again on top we provide there all the resources that belong to the program. So more on this later on when I do the demo in this regard. If you're interested in a little bit more background about myself, you can visit my personal landing page, hillpish.com. And there you find also a bunch of resources, mostly centered around Python for finance, AI, algorithmic trading, not that much about my personal things and hobbies. It's, again, I would say rather a Python for finance page than a personal page in this regard. Feel free to access all the resources. They're all for free, like videos, gists, GitHub repos, and so forth. Here are my 3 books. On the left-hand side is the Derivatives Analytics with Python. This is a quant book, I would say, which uses Python to illustrate mostly advanced algorithms for derivatives analytics. On the right-hand side is an even more specialized quant finance book, which focuses on listed volatility and variance derivatives. And the middle one, for which I think, well known, for the Python for Finance one, which came out in the first edition 2014 around Christmas, and the second edition was just printed again around Christmas. So roughly 4 years later, when after second edition, over the 4 years, so many things have changed, and we saw so many updates, upgrades with regard to packages, new packages on the horizon. So it was real fun and also exciting to update this book. Oh, I'd rather say upgrade, because mostly there were major changes, not only minor ones that we have made. We have added, for example, 3 chapters, a whole part on algorithmic trading. We've also restructured the basic chapters, or the chapters that cover basic topics, like, let's say, object-oriented programming, for example, or working with pandas and numpy. So the introductory chapters are now separated into a single part. So I'm pretty sure after the program, you know quite a bit about the contents of this book, because it represents the basis for one of the major classes, the Python for Financial Data Science class. Basically, you can say that I have written 2 more books on the topic, but we present them only online. The first and the larger one, in terms of page count, the PDF version, is the Python for Algorithmic Trading one. This is really at the core of our program. In PDF form, to which you have access, it has close to 500 pages as well, and it covers from my point of view, the most important topics when you want to get started, when you want to get to the next level with Python for algorithmic trading, among others. We cover, for example, 4 different trading platforms. The one is Wanda, then we cover FXCM, we cover Interactive Brokers, and also Gemini for cryptocurrency trading. And around that, we provide basically background information to then implement, indeed, algorithms formulated in Python in an automated fashion in the cloud. So this little sentence has quite a lot of know-how and skills attached to it when you want to get down to it. And this is what we try to cover in the core class. So this will also be your companion throughout the program. One of our major focal points over the last year, and even more so for this year, is what we call the AI machine. There we're building a platform for the standardized deployment of AI-based algorithmic trading strategies. The basic idea is that the user focuses on research and strategy development, and that the AI machine deploys robustly and reliably. It is, from the approach, a template-based strategy definition which kicks off the whole process. Then we have some standardized backtesting procedures, and we can run basically via a one-click approach Python-based algorithmic trading strategies in the cloud with real-time monitoring, multiple strategies in parallel, and provide also detailed audits and reports. So far, we haven't provided access to any third parties to it. We're still now in intensive testing phase, so Q1 will be mostly driven by what we think should be tested, and where we say, well, this is a reliable platform, and we'll get started with the use of the platform first internally. Maybe later on we'll then make it public. But I think I mentioned it here because it belongs pretty well to our topic here, Python for algorithmic trading. Indeed, of course, we use Python a lot, and for the algorithms exclusively, I can say, and of course a few other open source packages to get such a platform running in the cloud. As a summary for what we do here, you find in the slide deck 2 links to the PDFs. I don't want to go into the details. Both of these articles I think are a good overview of what we do, of what we have done. So feel free to read them. I think you won't need more than 5 minutes per article, and you have a summary of what we are doing at the Python Quants. Without partners, we couldn't do what we do. So For example, today I will show a demo based on the previously Thomson Reuters, now Refinitiv Icon API. So Thomson Reuters was renamed, at least Financial and Risk Unit, after the carve out by Plexstone. And we work together, for example, with regard to the For Python Quants Bootcamp with Fitch Learning and the CQF Institute. And the certificate itself, when you go through the whole program and prepare the final project, will be awarded by HWSR, which is University of Applied Science here in Germany. So I'm pretty happy that we are able to work with these partners, and they help us in many different respects to provide what we are providing to the Python community and the financial community in this regard. So before I go to the program, just mentioning, you have the options to ask questions throughout. So I will have a look at the questions via the webinar panel. You can formulate your questions, and I will sometimes answer them immediately when they fit pretty well into what we are just covering, or I might collect a few questions to answer them on block later on, but usually all the questions that are raised will be answered in due time. All right. The program, yeah, it's a 16-week program. We have some 150 hours of instruction. We sometimes replace, substitute certain elements. We add new elements to the mix. So this is kind of like a living body, I can say. You get access to thousands of lines of code and quite a comprehensive documentation, both in an online form, like HTML based on the platform, but also, for example, to 2 PDFs that we provide. So you will have access to quite a bit, and that's quite a bit to be covered over the course of the 12-week formal program. But I'm pretty sure you will get through it, and there is no harm if you might take a little bit longer. You have indefinite access to all the resources, and you can revisit them as you like and can study certain parts, for example, completely self-paced, if this is what fits your schedule. Because we know that many of the participants are working in a professional capacity and have tight schedules. So some wait, for example, for, let's say, a longer holiday where they can cover quite a bit of ground. Others like to work on the weekend instead during the week. So we have dealt with all these kind of backgrounds, and usually given our approach here, everybody can like fit in their study into any kind of schedule. Here, a little bit more of a detailed overview. Of course, many things will be based on Jupyter Notebooks. This is one of the major teaching tools. But of course, we provide also, like, let's say, proper codes. And this is not only Python. So, for example, in the tools and skills part, we will cover quite a bit of ground with regard to setting up a proper cloud infrastructure. And there we'll work with some bash scripts as well. But of course, the program is called Python for Algo Trading, and Python will be the dominating language and technology that we are going to use. So quite a bit. And again, it is at your disposal. You have access indefinitely, and you can revisit anything that you like also later on. If you think in terms of topics or topic blocks, I could say, of course, there is the Python side where we cover Python itself, then some tools, IPython and Jupyter are here in focus, also Docker container and cloud instances, basic idioms, control structures, linear algebra, basic finance. So this is what we need actually to do Python data analysis, Python financial analytics. This is the one part. Then when we think in terms of trading, algorithmic trading, the question is how we come up with strategy ideas in this regard. And this is where more the financial data science part, the analysis of historical financial data, the use of machine learning and deep learning techniques, for example, deep neural networks, are used to come up with predictions where we are concerned, for example, with backtesting. This is the first part, and I think in the world these days on the web you find quite a few platforms that support you pretty well. If you want to do something like this in the cloud, Maybe not with all detail that we're going to cover, but to some extent you can do some proper backtesting, say for example with Quantopian. But when you have a strategy and you want to deploy the strategy, then it's getting involved. And this is where the third part here comes into play, where we are going to deal with streaming data and visualization with real-time online algorithms instead of the back-tested ones, which have more kind of an offline or static nature. We will deal with real-time communication, meaning, for example, placing orders in real time, and the online platforms and APIs. So this is what you need to then get started with the automated execution and deployment of your algorithmic trading strategies. And be assured this can be a much harder part. Even for a pretty simple strategy, it might mean that you need to take care of quite a bunch of things in terms of real-time and automated deployment. And for some of you, it might be then time to learn even completely new technologies that you haven't had in touch with before, like setting up a cloud instance, working with a few bash scripts, and dealing with elements that are not typically part of, let's say, a standard programming or data science curriculum. And in order to then get a firm grip on all the topics and to master the topics as far as possible, at least, we have the do-it-yourself modules, the practice modules, where you should come up with your own strategies, where you should implement backtesting programs, you should come up with your own trading code, and you will have an own full week experience, which might lead to a research project, but it doesn't have to. They can be completely separate. Where you should then test where you might have some gaps with regard to the topics covered, or where you say, well, this is fantastic. I've never heard before about using technology ABC, and now I have deployed this particular technology to my own training algorithm. This is indeed what our goal is. Not that much to introduce only theory and algorithms and do a little bit of backtesting in a sandbox. No, you should get real. First, of course, when you work with a platform with paper money, but if everything runs smoothly, you can usually kind of quickly switch and decide to go live and then deploy strategies with your real money. Maybe also starting small, but this is the point where we say, well, we have reached a milestone. This is what I would consider success, when you say now everything is running smoothly and I have trust in what I have built there and can get started with real trading. The first class is about finance with Python. I say first because in my world, this represents the basis for everything. We have come up with this class, finance with Python, due to the fact that many people sign up for our programs and they either have a strong programming background. For example, let's say they have done some data science, but not that detailed knowledge about finance, for example, and or financial markets. Then we have many people that have a strong background in finance and the financial industry, might be trading for years and now say, well, I want to automate things, and friends of mine recommended to use Python. So this is kind of like to level the playing field and to get kind of like to the basics quickly and upfront, so that everybody has heard of certain financial notions, that everybody has had a gentle introduction to the first Python topics. And this is what this class is about. Throughout, we try to keep the classes with regard to data and so forth self-contained. So in the beginning, they don't rely on APIs or other maybe moving dynamic data sources. In this regard, there has been a question with regard to the Refinitiv partnership. Unfortunately, we cannot provide access to Icon Terminal. This is a paid subscription, but since I know the global product manager for Icon pretty well, and I recently talked to him in New York, he confirmed that they are working on let's say, demos and entry licensing models that might make it attractive also to get started without paying, let's say, the full-fledged price for the full data offering that Refinitiv Icon can provide. So there is something on the horizon, but I'm not yet aware of the specific timing there. Getting back to finance with Python, this is mostly based on pretty simple examples. And in this regard, it hardly deals with real world financial data. So this is more the theory part to learn about the notions and to apply Python to financial ideas. And me, for myself, having a formal education in economics, in particular financial economics and mathematical finance, this is typically how these topics are introduced, that you get started with some pretty simple two-state economies, and you learn to know about certain fundamental theorems. So this is the most simple case that we can consider, 2 points in time and 2 states only. You might then move to a 3-state economy where you can deal with notions like market incompleteness. And in the next step, you might add even more states of the economy. So you get to a static multi-state economy. You generalize the state space. And the next step then would be to go to dynamic economies, which are kind of like the most important foundation in finance these days. And you then see dynamic structures, maybe represented as trees or, for example, in the form of Monte Carlo simulation. But many well-known theories like the Markowitz portfolio theory, modern portfolio theory, or the capital asset pricing model, that can be cast already in all these static settings. So some of the most important and most popular, most widely used theories, they fit already into such a static economy, and this is what we try to introduce in this finance with Python, and we can apply, let's say, linear algebra approaches by the use of Python there. Don't be afraid, all the notions are introduced and the examples are that simple that basically you could solve them and replicate them all with pen and paper in this regard. We will see in the demo that we have kind of like different areas where you can access the resources for finance with Python, but this holds true for other classes as well. So here we have, for example, the HTML-based documentation, then we have several videos, and we have executable Jupyter notebooks. So these are the 3 cornerstones with regard to the resources for this particular class. During the demo, when I dive into the Quant platform overview, which will be a quick run through, I will show you how to access the different areas and how to go about them. Also, how you can access the Finance with Python PDF, for example, if you want to download this on your iPad and want to read it on the airplane or maybe on the train when you commute to work in the morning. Tools and skills. This is an addition we did last year because we noticed that without a proper understanding of the major tools and having mastered the skills to deploy, for example, algorithm in the cloud, it's pretty hard to get to the goals that I have formulated before. And here's one of my favorite quotes. It's from the Book of Five Rings. It's a book written by a famous samurai, Yamamoto Musashi, and it says, in building a house, there is a problem of the selection of wood. So this is what we are dealing with, our basic building blocks. But now it comes that it's essential that the carpenter's aim be to carry equipment that will cut well, and when he has time to sharpen that equipment. So Python and let's say bash scripting might be our wood here to stay in this analogy, but we will need, let's say, editing tools. We will need to know how to do version control, how to do proper documentation, how to work with cloud instances and Docker containers locally, for example. And this is what we subsume under tools and skills, so that you not only learn the core of the core, but also can get an understanding of the major tools, technologies, as well as the skills required to work with them. In this regard, we have come up with this quite comprehensive class, which covers first the basics, Python installation and environment. We differentiate there in the Mac and Linux world and in the Windows world. Then we introduce also Docker usage and the deployment of Jupyter Notebook, again, differentiated in the 2 worlds. We move on to cloud usage for the 2 worlds. So things are not completely different, I would say, but there are some minor differences which sometimes might be hard to get around when you see, for example, how it is done on Mac and Linux, and then you want to replicate this on Windows. If you don't have that much experience with, let's say, working on the shell or using PowerShell on Windows 10 Professional, for example, then it might be a little bit tricky. And this is the reason why we have differentiated this in the two major platforms. And then we throughout apply a number of basic Linux tools and cover also some shell basics. But this is more an ongoing topic. This is not a class in and of itself. This fits into these three modules times two for the platforms as well as into the rest. Then we have the development, which is here the middle column, if you like. We cover, for example, Vim for code editing. I will use briefly Vim as well today. Then what I think is a nice lightweight tool chain, Screen plus Vim plus Q, which is about editing, logging, debugging, and session management on Linux platforms. Again, we have like the background that we work not only locally on a Windows machine or on a Mac or what, we might be working in the cloud or working in a Docker container where we just have the shell, and this is kind of like a lightweight setup that we can basically use in all these environments that I just mentioned. Doc tests and unit tests are one session in this regard, also Git version control. So again, this is about coming up with code and managing the code. Then the third column here is the distribution column. That's Python packaging, how to structure Python packages. Once you have maybe more than a single Python file, a Python module, you might start thinking of how to best package it. This is about the structuring of files and implementing certain rules that you need to follow for a proper Python packaging. Documentation is also a topic. Here we cover, for example, the powerful things documentation package, which allows you to create the typical HTML-based documentation and or PDF versions of your documentation, which you might have seen maybe quite often for packages such as pandas, numpy, and so forth. So they basically all use the same infrastructure which we covered there. Then you might be at the point where you say, now time is there, I want to share it, either, let's say, internally, just with a small team, with your friends or with your colleagues within a company, or you want to indeed open source it and share it with the world. And this is our background here, that we show how to host code publicly on GitHub, for example, coming up with a README file so that this all looks kind of nice. And last but not least, we will have a case study which goes through all the steps from A to Z, if you like, and summarizes and recaps what has been covered before. So I think it's quite a comprehensive program for the use of Python and other technologies in the context of algorithmic trading and the deployment of code in the cloud for the automated execution. There are four major building blocks that we have. So Jupyter notebooks are at the center. This is something we, no matter what infrastructure we might want to deploy, we might carry around with us also as our tool set in the toolbox, IPython and Vim. So this should be available no matter what we do. On top, we have then Python itself. So once the tools are there, of course, we want to do probably some coding. And the packages, tools, and maybe a bunch of environments that we're going to manage, we can manage based on the Conda package manager, sometimes here and there using also the standard pip package manager. Then we might come up with some Docker containers within which we have our own operating system, runtime, and so forth. For example, when you work on Windows, this allows you to easily work with Ubuntu Linux operating systems on your Windows machine without getting into conflict with what you have installed there. But this works on Mac as well. So here on my Mac, I can easily run a Ubuntu container, for example. Then last but not least, if you want to run something which should run, let's say, 24/7 or at least 24/5, for example, when you trade FX algorithmically, then you need something with high availability, which is independent of your local machine. And this is the point typically where you would move your code into the cloud. And once you have trained all these elements, this shouldn't be too far away, and you can get started easily there. With just $5 per month, you get already a proper instance in the cloud by DigitalOcean, from DigitalOcean. And this would allow you to run your algos already, let's say, on Wonder, if there is not too much analytics involved. Let's say you have a technical trading strategy, that's already what you can use for that. But it's also easy to resize and to go bigger if there is a need for that. The resources are provided similar to what I showed before. So we have a bunch of videos and recordings of the sessions, plus also here in this case some gists, which provide you with certain bash scripts, Python scripts, and other background information that is important to the single sessions that we have in this class. In the meantime, there was another question with regard to data sources. Basically, I mentioned it before, and this is now a good point to pick this topic up again, Python for Financial Data Science. This is one of the classes where we work with real-world financial data. And after experiences over years and working with dynamic APIs and having experienced the shutdown of the Yahoo API and the shutdown of the Google Finance API in this regard, I decided to go with static data sets. So we try to make everything as replicable as possible by providing the fixed data sets. Either we provide them directly, or for example, for download, for remote retrieval on remote data from remote data sources like my private server or other data sources, and you can download them and can work with them either on the Quant platform or on your local machine, let's say, or on a cloud instance you have set up. So this is the basic approach. Having said that, of course, once you have gone through examples and once you want to work with your own data sets, feel free to do so. If you have access to the Bloomberg terminal, or you have access to any other data source where you say, well, this is what I typically work with, it should be easy enough to replace what we provide as data sources by your own data sources. As long as you have, let's say, a halfway standardized data format, Python and Pandas in particular will help you getting the data into the format that you can then use to work with. So this is indeed what should be the approach, that you say, well, maybe I could start it with the provided data sources and later on I use my own data sources. So having a look at the overview here, again, it starts with the basics for this class, which means Python data types and structures, numerical computing with NumPy, data analysis with Pandas, and OOP, object-oriented programming. So equipped with these tools and with this background knowledge, we can then move on and cover important data science topics, such as visualization, such as, for us, financial time series, and, for example, performant input-output operations and performance Python. So this is kind of like the point where we get started, moving around and visualizing larger sets of data. So it's the middle part. And of course, financial analysis is mostly applied mathematics. It's a discipline in applied mathematics. People speak of mathematical finance or financial mathematics, or there's so many terms like financial engineering. They all somehow point to the fact that math plays a major role there. And that's the reason why we cover the most important math tools in a separate stream here, or part. This is the third part, mathematics, where we cover basic mathematical tools. Then we cover stochastics, meaning we do some Monte Carlo simulation there of random variables, but also stochastic processes, and also statistics, as well as machine learning. So we could say econometrics and machine learning here in this regard. In machine learning, we cover on a fundamental level different approaches like unsupervised learning, supervised learning, estimation, classification. So these are topics that are covered there, usually based on a pretty simple examples, so that you don't need to deal with the complexity of the data set and can rather focus on the application of the algorithms. There is one special, this is in the book, this is the appendix. This is about dates and times, which are important, I think, not only in finance, but in finance in particular, alone when we talk about financial time series management. Here, dates and times play an important role. And when you import, for example, financial time series data from a certain source, there might be the need to transform the date information to other formats, to Python based formats, or something that pandas provide. So these are all topics that are covered here in this special part, which is an appendix in the book Python for Finance, first as well as second edition. As before, we have the resources. The printed edition of the book is not included, but the HTML version of the first 13 chapters is provided on the platform. And there is also, as you can see here, a rather lengthy list of video resources, video instruction, plus, of course, a Jupyter Notebook. So this is what we have here, and which you can access on the platform and can execute on the platform. In the meantime, there was a question with regards to quizzes and exercises. So far, we have kind of like exercises and review work only rudimentary in some areas, but it is something that we want to add slowly to the mix here as well. So basically, the major test for you will be the 4 weeks where we implement the practice module. So I'm a big fan of practice, schools, and doing. Not that much of, let's say, multiple choice tests, because they only indicate in general that you can recognize certain things, but you won't be measured in the real world by what you know, but rather by what you can implement. I will argue with regard to practice and the importance of practice in the final section today. You saw it in the agenda. So, but again, we have this on the list, and we will add to the mix also quizzes as it was asked for, or I would say exercises and recap work there as well. Python for Excel, also a rather recent edition. We have updated this. I will have a demo about this as well. This is a class which shows you how to combine Excel with the analytics power of Python. And I know that many active in the financial industry are still using Excel for a diverse set of tasks and diverse use case scenarios. And I think adding Python to the mix in this regard is really a powerful thing. So my demo will only scratch on the surface today, but be assured, making use of Excel Wings in this regard. This is the, I think, leading Python package today. You see it here, imported, import Excel Wings as XW, will give you indeed the best of the two worlds combined into a single technology setup with quite a bunch of examples and use cases illustrated during this class. Python for databases, also something we have added last year. Here, this is about the use of database technologies to efficiently manage large financial data sets. This is a 6-part class, so 6 sessions there. Python for Excel has 4 sessions, and we cover not only the SQL and NoSQL parts here that are pretty common, like MySQL, SQLite, and MongoDB. SQLite, for example, being one database technology which typically comes as batteries included. We also cover, let's say, more specialized Python packages like PyTables, which allows the binary storage of, for example, financial time series data. SQL Alchemy, which is an abstraction layer where you can exchange different backends under certain circumstances for your development work. And bcalls, which is a columnar storage technology which can speed up certain operations for data storage and retrieval pretty quickly. We have this introduction and motivation part where we highlight a few problems and how they can be solved with what we covered there. And we also provide a comparison of the different technologies. So afterwards, you should have a good overview of the single technologies and could say, well, this is now my problem. Let's get back to Python for databases and let's pick the right one. And you should be well equipped to come up with the proper technology to deal with larger data sets in this regard. Resources, as before, the recordings. I mentioned 6 videos are available in this regard. Many things will be done here on the shell with regard to setting up. In order to get started here, you should have at least a basic understanding of how to work in the cloud, because this is all structured to be implemented on a cloud-based instance, because we don't want to mess up with local installations. So at least a Docker container, but preferably a cloud instance. Even a kind of a smaller one should suffice to implement this whole class, where we provide installation scripts and everything for the automated deployment of the resources in the cloud. So it's something that we, for example, can't do properly on the Quant platform because it's a more closed environment, but with your background knowledge which you should have gained by that point when you get started here, you should be kind of able to straightforwardly set up everything required in the cloud. Natural language processing, also a pretty new addition on our curriculum. This is a class. Currently, it stands at 2 sessions, but we have provided with this class a bunch of resources which we ourselves came up with based on different sources. So I think the major benefit of this class is that we provide you with a bunch of pretty helpful helper functions, Python-based ones, and also with regard to a few other technologies that are covered there, and that you can reuse to implement your own NLP projects. So because these days it's not only structured numerical data, financial time series data that we deal with on a regular basis, it's also unstructured data. And via the APIs of, let's say, Bloomberg or, for example, a Refinitiv Icon, we can read unstructured data. And for example, we have implemented a project last year with Dow Jones. They have come up with a new offering. It's called DNA. And via this offering, you get access in static fashion to 1 billion articles. So just think of the number, more than 1 million news articles are created on a daily basis. Probably not all of them are relevant to what you're doing or what you're interested, but having such professional data sources with meta tagging and pre-screening and so forth makes it kind of really worth the while to have then the respective Python functionality available to process unstructured data at scale. And again, I'm not only talking about some tweets, which are really noisy. A few research studies have been implemented this week. I'm talking about professional, reliable financial press resources like, let's say, the Financial Times, the Wall Street Journal, and so forth, that you basically can read with Python. And by read, I mean reading and interpreting and coming up with summaries and relationships between certain articles and similarity measures and so forth and so forth. And we provide you with the tools required to at least get started and to get to a slightly advanced level. From there, you could then take it to the next level, given what your specific goal would be with regard to natural language processing. Artificial intelligence in finance. So this is now a new class that we start with this cohort of the Python for Algorithmic Trading certificate program. It is based and will be based on work that we have been doing, let's say, over the last 18, 24 months. We have, of course, already some AI built into the whole program, but this will be on a more general level, arguing why AI might be a major influence for finance and the financial industry in general for the years to come. So in this regard, I have here my one major overview slide, which I typically show in this regard. When we think in terms of financial markets, I have here this pretty simplified idea of lots of data, this X, and this X is getting bigger and bigger as we go. So more or less on a daily basis, more and more data is created and is also available to participants in the financial markets. And the markets themselves, they act as information processors, like a big processing machines, digesting whatever comes up in structured, unstructured form, real-time, historically, and whatnot, and comes afterwards, after everything has been digested, up with, let's say, new prices, new numbers, new developments, and so forth. So in that sense, we can think of a financial market basically as a pretty complex function which takes X as input and yeah, spits out Y as the output. Of course, X and Y are huge entities of data. And this is happening in a real-time fashion. And I think it's rather safe to conclude that markets are nonlinear, complex, and changing over time, as far as we can tell when we have a look at the data. But when we contrast this with the history, finance history, basically all the theoretical success stories, and I mean all those success stories that might have led to Nobel Prize in economics, have been mostly normative economics, in the sense of that they rely on certain assumptions, axioms, etc. Basically, what a brilliant mind thinks how the world should work. And the result often have been, I write here in parentheses, too simple and elegant theories. So when I say, well, a market is like a huge function taking a multi-dimensional input and providing here, delivering a multi-dimensional output, this is like what it is. And sometimes, although we know that X is pretty huge and Y is pretty huge, elegant theories take as input 1, 2, 3 parameters only and come up with a single number only. So, for example, the Black-Scholes option pricing model, which many of you might be familiar with, takes as input 5 or 6 parameters in its basic form. And it comes up with one output value, like a price for a European call option, let's say, on a certain stock, paying a dividend or not. So this defines mostly then the number of parameters, 5 or 6. And the example that I picked, this can be said to be a success story. So most of the derivatives analytics models that people have come up with, they are still reliable these days in practice. Of course, there have been changes over time, but many of the even more popular model, like let's say portfolio management theory and capital asset pricing model, like the CAPM, which is the typical abbreviation, or APT, the arbitrage pricing theory, which takes as input a bunch of factors, that might be indeed too simple and elegant. So they hardly have any supporting empirical evidence which would support the theory. What AI in finance means, and this is sometimes what I then call finance with the AI in the middle here, is it brings us back from normative economics to positive economics. We have a look at data, at relationships, or we can say at hard science, right? Like physics. In physics, typically, people first try to get the data and then try to come up with relationships and assumptions. Of course, in reality, is not that pure that you start with data only and then come up with relationships. You might get started with hypotheses, but once you find contradicting data, you might revise your hypothesis or even reject it completely. But I think the major point here is getting from some normative idea to say, well, markets should work somehow like this. We get back to positive economics, positive science, that we say, well, this is what we observe. And now let us apply general parameterizable trainable algorithms like our machine learning, deep learning algorithms to the data that we observe, maybe with a bunch of parameters, hyperparameters on top of that. And we might come up with something that works kind of okay in the market. So it might be better than the nice, elegant theories, which have been brain-driven and are pretty beautiful. But here we might have something that works, but might not be as beautiful, as concise. We are dealing with a black box. But believe me one thing, if I would have something which might be a little bit obscure, which might work like a black box, but nevertheless performs better in financial markets, for example, in the context of algorithmic trading, I would rather go with this data-driven, positive approach and apply AI algorithms that might be, yeah, a little bit more complex than the simple financial theories if they work in practice. Once it gets to money, and in particular to my money, and I think you will see it with your money as well, you rather work with something that might work kind of okay-ish, even if you don't fully understand it, as compared to a nice, elegant theory that you can prove mathematically, but which doesn't have too much support in practice. So that's the basic idea, and this whole class will be more, let's say, experimental. We get just started with this class. I will present certain ideas, certain approaches, but I'm also planning to cover there such important algorithms as deep neural networks, making use of keras. This is a new package we introduced into the program. Also using keras, for example, for reinforcement learning, which has come to prominence recently through all the success stories reported by DeepMind in the context of Go playing, chess, and playing Atari games and so forth. So we will see quite a bunch of interesting things which might have a lasting influence on our discipline. Now getting to the core of the core, Python for algorithmic trading. This is basically divided into 4 parts, and when you see red dots here, this should indicate what my demo will be about afterwards. So I will cover during my demos a few topics there, but let us go through the single blocks here step by step. There is the introduction to the Quant platform, then we cover Python environment and infrastructure. I will quickly illustrate how to set something up in the cloud. Basic finance in complete economies, basic finance and incomplete economies. So this is what we would consider the foundations in this part. Then we cover core packages, usually against, of course, the background of financial data science and algo trading. So dealing with financial time series management is one of the major topics there. Stochastic and statistics coming from the financial data science class will be revisited here. And we might do some special and advanced topics. Then algo trading itself, of course, deals with financial data. We do backtesting there. We try to do predictions. For example, making use of all the technologies that I mentioned so far, like deep learning, standard machine learning techniques. Let's name a few, like Gaussian naive Bayes, or maybe decision trees, or we might use logistic regression or support vector machines. These are different algorithms that we might be using there. Then we also need to take care of streaming data and visualization. Important topic, because in the real world, when you want to do algo trading, things are moving and are happening in real time. So we cannot lean back and say, well, now give me 5 minutes until I come up with the next prediction. We need to digest the data in real time, and maybe need to visualize it in real time as well. Without a proper trading platform where we can place our trades, no algorithmic trading in its original sense. I pointed out we can get started, of course, with paper money based on demo accounts, but at one point we might want to deploy our own capital there. So the 4 platforms that we cover are listed here: XCM, Wanda, IB, Interactive Brokers, and Gemini. Then the automation of algorithmic trading operations. Once we know how all this works, we need to take care of the automation aspect. We need to deploy our stuff in the cloud. We might want to come up with functionality and capabilities of for the real-time monitoring, and a bit more. Also, logging is a topic in this regard. Then the experience pillar or column here, there is out of some backtesting practice module where you should backtest your own strategy. You then should test it in live trading for a single day, and then you should try to run it for a couple of days. There's a little bit of a difference when you say, well, I do it for 3 hours straight, or I do it for 3 days straight. And this is actually the learning curve that we want to provide you with. And the final project is then delivered as a Jupyter notebook. Oh, here is the automatic spell checker has done its work. So Jupyter, of course, with Y here, Jupyter notebook. My thinking typically is in terms of 7 layers, and you will see this pyramid quite often. We start with the infrastructure, we then have the financial data that we deal with, we formulate strategy code. This can be as simple as 2 simple moving averages, or this can be as sophisticated as a deep neural network model that we use for prediction. We cover vectorized backtesting, which deals with complete data sets at once, and we cover event-based backtesting, which gets closer to the real world in that data is dealt with incrementally. So we go data step by data step. And of course, when you think of the real world, then we also have kind of a constant inflow, step by step, data point by data point of data. And this is what event-based backtesting should simulate. It also gives us a little bit more freedom and flexibility to formulate strategies and to do backtesting as compared to the vectorized approach. Then the connecting code. This is all about the streaming data and digesting data in real time. So this is what we have at this point. The trading code then is based, of course, on the connecting code, but here we add to the mix the placement of orders, buy and sell orders, maybe checking also the accounts and dealing with stop loss and whatnot. And last but not least, this is here the highest level. Once we have implemented everything, we should make sure that it runs properly in an automated fashion in the cloud. So this is my thinking, and we start with the infrastructure and we go through all these steps in detail, and the resources are structured along chapters that cover different topics. So for example, when we get to connecting and trading code, this is covered for all the 4 platforms that we are going to cover in detail, one after the other. So for all the 4 platforms, you will see how you can connect to the platform, how to retrieve data there, and how to place your trades, and also maybe how to automate things when you do it there. So in that sense, this is our red line through the program, plus left and right, all the other nice classes when they say, well, but I want to use Excel for this and that. I have lots of data. I want to make use of a database, or I want to enrich the analysis and my trading by some unstructured data sources. So this is where the other classes then come into play. The study plan. You have access to the study plan. It is hosted on the certificate. TPQ. I'll go through it. Here we go. I'll go through the study plan, January 2019. This was updated as of today. This starts with the overview and some general remarks, which explains also what the certain columns are about. But the major thing here is this table, in particular for the first 12 weeks, where you see week by week what is on the agenda on your study plan. And for example, here in the core certificate program part, it starts all with finance with Python. And we also want to cover in Python for financial data science, basic data types and structures, tools and skills, get started with Python installation and Python environments. And there is also this part about the reading resources. So there are 3 reading resources on the Quant platform. I will show you this when I get to it. And here in this column, we will list the live sessions for the particular week. So in the starting week, we have 3 live sessions, the one we are currently in, and then 2 more over the course of the week. And then in the final column, there are the optional resources. And I consider Python for Excel and Python for databases and natural language processing optional, in the sense that you can do everything else without having covered these optional resources. But of course, if you say Excel is pretty important for me, this might be something that you might want to get into from the start, or maybe a little bit later on. But basically, this is the recommended sequence, but there is no big issue if you get started, let's say, with NLP and do Excel last. For the PyDB class, at least you should have a little bit of background with regard to cloud usage. So that's the reason why we have started this here. So a little bit of cloud usage should be known to you, the basic things, and then you can easily set up everything that is required for Python for databases. The rest then similar to the first week until we reach week 12. And after week 12, we have the practice modules 13 up until 16. But more on this on a weekly basis. We send out weekly orientation emails where we recap quickly what is on the agenda for this week, where we highlight certain topics and provide a little bit of guidance here and there. So this is something you should follow along, and usually I send this email out on a Monday morning. So when we speak of a week, we have the Monday as the starting day. I have this study plan also here in the slide deck based on screenshots. Again, this is basically now the same state. Also in the slide deck, the link once again to this study plan. So there might be some questions. Let me quickly have a look. Yeah, there is a question with regard to the numbering. And the numbering is as follows here on that side. And when you have a look at the orientation email, I typically write behind in brackets whether this is a video or not. And these are all videos. So Finance with Python 01, Finance with Python 02. This is meant to refer to the respective video. And when I say Finance with Python chapters 1 to 3, this is the reading material. So this is HTML or PDF, and this is video. But in my demo, I think you will immediately see what is meant by these different things. There's another comment that this looks like a bit of work. Yeah, first of all, we have optional resources. Second of all, you can do it completely self-paced. I mentioned that 10 to 15 hours per week is what we have in mind, typically as the workload. Of course, sometimes you might be a little bit more busy and you can catch up the week thereafter. We have also planned for weeks where there is a little bit less, so that you have the opportunity to recap and revisit certain things. Overall, most people get through this program, also maybe emphasizing certain elements that seem more important to the individual delegate in the program. But many who have, let's say, full-time professional work to do, they decide maybe to go at a little bit of a slower pace, or maybe focus even a little bit more. But I'm pretty sure once you get started, you get a good feel for what is the best approach for you with regard to the study plan. That's also one of the reasons, and you might have noticed it, that I call this an example study plan. So by no means we expect you to go through this, let's say, in a detailed fashion, and once you miss like, let's say, one single element in 1 week, that you missed the whole thing. No. This is an example study plan, and it provides you, I hope, with enough flexibility to focus and to maybe go in certain areas in a different sequence in this regard. But the sequence has, of course, some sense to it, as I pointed out here and there already. So the sequence has proven to be a useful one, as you see it in the certain parts there. Another content-related question. So far, what we do is mostly concerned with single instrument-based strategies. Of course, the same holds true for a program or a training class as holds true for a book. You need also to decide what not to cover. So mostly what we cover are single name instruments, like, let's say, a single FX pair or a single stock that we use as an example. Not that much, for example, baskets of stocks or, let's say, pair tradings. But for example, we have had quite a few students in the past that have decided to cover, for example, pair trading strategies during their final exam. So nothing prevents you from coming up with these elements, and it might be something we add in the future as well. But related to one of the previous questions with regard to that, there's quite a bit to cover. And we know that. And again, we need to make some decisions. And this is one of the decisions that we've made, that most examples are based on single instrument strategies only. But feel free to go with multiple, let's say, pairs or baskets if you feel you have mastered the basics based on a single instrument. Now it's time for a few shorter case studies and demos. Now they are just meant to whet your appetite, not as much as like going into details and in covering every single element that might be interesting or important, nor maybe to answer all the questions that might be related. So everything that I'm going to show is covered in much more detail during the program. So this is indeed to whet your appetite and to show what to expect in certain areas. And the first thing I want to get started with is the Quant platform. Also not on the most detailed basis, but at least to put you in a position that you can get started with first week's program and that you know where to find all the resources. So here I'm already logged in on the Quant platform, and without going to the tools yet, you find here under my trainings, this is the major part, you find certain resources. So there is a little blank in between, and the first three, these are the written materials, the reading materials. And you see here a little button which says update, and I'm going to click this update button. And it says something about caution, and I say, well, I understand what's happening here. I haven't changed my things, but nevertheless, if I have changed something and I want to later revisit it, it will move to a subfolder old version. So because we have just updated actually this morning Finance with Python to a new version, so it's brand new. Not brand new in terms of content, but brand new in how we present it, how we have technically implemented it. So this has been successful. And again, these are the reading materials and these are the classes. So when we now have a quick look at the study plan, to this end, I go quickly back here. And we have here this first week in the study plan. It says Finance with Python 01 and 02. This was one of the questions. So I can go here to the videos. This is the video part here. And it opens Finance with Python. And here you see 1, 2, 3, and 4. There are 4 videos, and the first 2 are on the schedule for first week. And I can click on this, and it loads here on the platform the video, and I can let it run. I can watch it, I can listen to it, I can skip forward, and this would be the first video actually. So there's of course also the second one for the first week, but this is the area where you find it. Finance with Python. This is where you find the videos. Now, you can also click here on Finance with Python 01. This blue line here is a link. So you see how the cursor changes. And when you click on it, there you see again the link to the video. You see also a little bit of text. In particular, also a link to a slide deck. So here in this regard, I can click on it and it opens another slide deck, which is meant to be used in combination with this program. So this is there available as well. I can close this. But also, in particular, there is a bunch of resources down here, and you can double click, for example, on the first Jupyter Notebook. When I do a double click on the Quant platform, it opens the Jupyter Notebook, which you can then execute and use on the Quant platform. So this is how you get access to the related Jupyter Notebooks. But this is only one part of the resources. So let me close this so that we don't have too many things open. Recall, we have here training Finance with Python. Here I can click on the video opens. Then I can watch it. Or I go to the module itself, Finance with Python. There I find text, usually some links, also the video link and a few Jupyter Notebooks on which I can double click and they open immediately on the Quant platform. So this is the Jupyter Notebook. Let me close that one, maybe here that module, and also this video. You also find here under reading material, Finance with Python chapters 1 to 3. So this is now the text, and you see here up there Finance with Python, and you can click on Finance with Python. You see here, this is January 2019, so brand new. I told you, it's updated today. And now it means chapters 1, Finance and Python, to chapter 2, two-state economy, to chapter 3, three-state economy. So these 3 chapters are the reading assignment for the Finance with Python class. It is all meant as supplementary material. If you say, well, I'm rather like the practical guy, first I want to get started with programming only and later on revisit that, this is also possible. But if you see something on the coding side and listen to the video and say, well, now this is a particular point, I need to have a look at the documentation, then you can refer also here to the documentation. In some parts, it might look a little bit formal, but the examples themselves are all pretty straightforward and simple. So staying with this class, you have even more resources. The one here is in FinPy. Up there, you see there the folder which is called FinPy. And when I quit on FinPy, here something seems to be running. Maybe I open another one like FinPy 03 for the chapter number 3, because we just have this open. Here, Finance with Python. You see here the text. I might go to three-state economy, and there is the introduction, and there it starts at a certain place with some coding, import numpy, np-random.seed, and so forth. And in this part here on the left-hand side, you see I'm in FinPy. There, the Jupyter Notebook provides you with the exact same code as is in the documentation. So there's no need to copy and paste or to look at the documentation and to rewrite what is there. So if you want to have like the quick route to the code, you can open the resources here, and the exact same code which has been used actually to come up with the text is presented here as a Jupyter Notebook. So this is what the platform provides you with. You see, alone for this single class, we have a bunch of resources, and I think once you get behind the structure, this should become second nature for what you do. I've mentioned PDF files already. So if you want to access a PDF file, you might need to go via the file manager. Here I open the file manager. And in the file manager, you see a similar structure to what we have had above here, for example. So, in this structure, and on the right-hand side, for example, when I go on FinPy, you see that this shows now the same contents. This is more like as you are used to on your local machine. This is like in a file manager, like in Finder on Mac, or in file manager on Windows. You have a look at your folder. One major difference jumps to mind, I think, and this is that we have here a PDF file, finpycourse.pdf. This is not shown on the left-hand side. This is an important point, that on the left-hand side here in this navigational structure, you will only find Jupyter Notebooks. It doesn't show, let's say, a Python script or a PDF file or whatnot. This is only for Jupyter Notebooks. But in the file manager, you see all files. So for example, here, I can click on FinPy course PDF, double click, and it's password protected. Everybody of you should have the password available. We have sent it usually twice so that you can access it here. And once I have provided the password, I have also access to this documentation now as a PDF. It has some, I don't know, 170 pages or whatnot, and it's now in PDF form what we present here as an HTML version by default on the platform. Now you might say, well, this is nice on the platform. I want to download it. You can use here right-click in the file manager, and then you click on download, and you can save it locally and can use it in different areas. So this is all possible. So you have now seen basically how to access all the resources that are related to one class. The same holds true. Let me quickly close the tabs here, so not getting confused. there. I'm going to close this thing, also the text and the file manager. Maybe at this point, you can always, of course, reopen it. There's not a big deal. But to quickly wrap up this part, when we look at the study plan, it also says something about Python for financial data science, about tools and skills, and here's some other reading materials. I quickly want to highlight these areas as well by going back. So the financial data science class is found here. So you can click on it. There are the modules. There's, for example, the module data types and structures and so forth. And you can access, as I've shown before, based on the Finance with Python class, the video from here. You can double click on the Jupyter notebooks and you can go in the same way. Then you might read some reading assignment on the study plan, and this is now in Python for Finance. And when it says, let's say, chapter 1 and 2, this will be why Python for Finance and the Python infrastructure part. So it's the same approach that we have seen with Python for Finance. Last but not least, we also have here the Python for algorithmic trading documentation. You see this stands in October 2018. When we have updated this for the last time. And again, let me have a look. Here the reading material says Python for algo trading, chapter 1. Then it is exactly this chapter 1, Python for algorithmic trading. And you should read, according to the reading assignment, this first chapter. So the structure throughout is the very same. For most of the classes, for some classes, there are also external resources in the form of the gist, but then you find it in the respective module. To show you this ones, let me close all these elements, because as an optional training, we have in the first week Python and Excel. Here, and I go to the module Python for Excel 01. Here you see external resources in the form of a gist. So the gist with selected resources is found under, and then you find this short link, this bit.ly short link. And this might bring you to a gist which is not on the Quant platform, and which you can use to download the resources for the respective class here, the Python for Excel one, to your local machine. But this is also explained and shown in the respective video. Speaking of the respective video, this of course here is the video which you access then via the same module, and you can go here to any point and go through the slide deck first, and maybe then here get started with stuff presented in gist form, and you download it afterwards to work with Excel Wings. Here, for example, and you see this, for example, is a class that we have done completely in Windows. For Windows, in Windows, the first 2/3 of this class work on Mac as well, but the final part, which is about user-defined functions, for technical reasons, doesn't work on Mac. That's the reason why we have done it from A to Z here in a Windows environment. So closing that one. Maybe showing you the other tools rather quickly. You have received a link to the Quant platform overview, which explains this as well. We have the task manager here, and you see there are now, since I haven't closed them, there are a bunch of Jupyter notebooks running. And every once in a while, you might check this and might say, well, this is something I don't need anymore. So I go and shut it down. I shut that one down, and I shut that one down. There's a terminal running, which I can open here, and it opens a terminal. Here you see that I've updated the FinPy resources just today. And this is a proper shell terminal, and I can do, for example, some code editing. I can start Vim here on the shell. And what you can also use is explained in the tools and skills class in terms of the respective Linux tools, if you have not yet that much experience with it. So it's a full-fledged shell where you can move around files, where you can rename files, and so forth, within your account for sure. You can also open a new shell by clicking here on New Shell. Then New Editor opens basically a full-fledged editing environment. Simple Python script maybe, and I would say import numpy as np, and I would say something like print np random, maybe some 10 random numbers. You see there's no syntax highlighting because I haven't saved this file, but I can say, for example, simple.py and save it now under this file. Oh well. And suddenly, now that the editor sees that this is supposed to be a Python file, it provides you with some syntax highlighting here in this regard. When I now open a new shell, let's say, a new shell, let me see what is there in my folder. You see that suddenly there is a file called simple. So when I now try to execute it, I can, for example, say Python simple, but it doesn't run it. Maybe I did something wrong here with my simple example. It currently doesn't print it, so let me quickly check here. I could also edit. So this is for you. If you say you are like let's say a Linux pro and you have used Vim, for example, intensively already, you can make use of Vim editing here, and I can edit it here. I don't know, for whatever reason it's not yet saved, so let me go and save it. This might be something that I have forgotten. So this was for me to check because it executed it, but it didn't show it. So I might now go out and can have a look at it. Now there seems to be something in there. So I've made sure that my code is now saved, and I might repeat my Python simple.py, and suddenly it works. So you see, you can have a full-fledged development process here, working on the shell, having the code editor here where I've changed the name, then I've saved it. I have opened here Vim for code editing. So this is basically all possible on the Quant platform. You can think of it like a full-fledged, web-based, interactive Python development environment. But I'm pretty sure that 80–90% of you will mostly make use of Jupyter Notebook because this is also our major teaching tool in this regard. I just wanted to show and highlight that we have this all available. I'm opening the user forum, and in the meantime, because this relates so pretty well to what we just do now, I will ask the questions, because the user forum is for your technical questions, for all your technical questions. So there is another question: how many people passed the final exam? This is a more general one. I can tell all those who have put in the effort, they all pass. We have many people that say, well, I want to do the program, but for me, the formal certificate is not the decisive thing. So therefore, I wouldn't come up with like a percentage point, but I can tell that all those, maybe after the second or third iteration, will be in a position to pass the final exam and get the certificate. But again, there are many people who don't even try to come up with a final solution because they say, well, I just wanted to learn about it. It runs for me, and the certificate might be nice, but currently I'm not willing to invest into this additional step. There is another question with regard to the passwords. The passwords are sent separately, and if you have a look at your personal welcome email and your registration email, they list the password. So just to avoid any confusion, the passwords that you need for the PDFs are different from your login passwords. Another question, whether you can open multiple sessions on PyAlgo. This should work, just give it a try, but basically our tab-based approach allows you to have many things running at the same time anyway, so by default. There's another question with regard to finishing the program in time. We have had quite a few who did it twice, or even sometimes people join a little bit later and say, well, now that I've joined late, I'm not really able to finish it in time. So one repetition, let's say, is typically not a big deal. But I think you should give it a try, and you should try hard even to get through it the first time and focus on the practical work there. I said that all these questions, if they are not too organizational or private in terms of data privacy, can all be asked in the user forum. And the user forum has different areas. Quant platform, you see here a few numbers, certificate program, finance with Python, Python for financial data science. Here, I think that's the most active one, Python for algorithmic trading, Python for computational finance, and also DX analytics. And depending on the major class or topic that you have, you can here visit the respective board, as we call it, and can maybe search through the user forum. Maybe somebody has asked the same question and somebody else has come up with an answer to the question, or you can here add a new topic and you can post your technical questions. Again, the organizational ones rather by email, but the technical ones, which might be of interest to many other people on the Quant platform as well, please post them on the user forum. And in terms of speed and response time, we get notified by every new post on the user forum. So if somebody posts here a new question, like here in January, we get notified immediately by email so that we can answer either by email or we answer here on the platform. Here I've provided, I don't know, a little bit of a Python code snippet, and this answered the question, obviously, in this regard. So please try to avoid redundancies by sending questions by email and putting them in the forum. Whenever you put something in the forum, you can be assured that it will reach us by email as well. So this closes the little tour here through the Quant platform. You might now have a good overview how to work with the different resources, the tools there. Also make use of the user forum, your training resources. The first three are the reading materials and then the single class to start. So for every reference made in the study plan, you should now be able to find the proper location here and the proper resource on the Quant platform. So let me close all these, that I'm finished, and here the study plan for the final look. So using the cloud for Python. So I will now do a little cloud setup because many people are a little bit afraid of setting up new cloud instances. Here I'm on DigitalOcean. I will create a new droplet and I show you how easy that is. Again, I'm going through this rather quickly just to illustrate it, not to explain it. I take here the smallest droplet that I have there. You see $5. I put it maybe here to Germany because I'm based in Germany. I use a SSH key. This all is explained in the resources, and I might call this algo cert demo, for example. I'm not allowed to use underscores, but I can use dash hyphen here. This is allowed, so you need to maybe see the rules, what you're allowed to use here as characters. And I can click already after these few customizations on create. And the value proposition of DigitalOcean is that it takes some 1 minute, some 60 seconds until they have commissioned a cloud instance for you. In the meantime, while this is up and running, there's a question how I recommend that you practice. I think when you get started with the classes and you go through all the materials, you get a pretty good feel of how to practice, to go through the different resources through the Jupyter notebooks, come up with your own variations and examples. I think this is the best practice that you can do, to come up with a slightly different example compared to what we cover and then try to solve the problem. So here you see AlgoCert demo. There is the IP address. This is the one that I need. I have copied it now. Go to my shell here and now say SSH root at the IP address that I've just copied, and it allows me to now log in, and I'm already logged in here. I usually do some housekeeping. First, with regard to the package index. Just takes a few seconds. You see this is finished. Then I do some upgrade to have the latest and greatest instead of some old risky stuff. And here we are mostly finished yet with the basic housekeeping. For example, I can use htop, which is not installed, compared to some other things. If I want to install it, this is all explained in the respective tools and skills class. I can here use apt-get install htop just to show how easy it is. It takes a little bit, it is installed. Now let me retry it, and suddenly it works. So this is a tool I regularly use. We show how to make use of also in the tools and skills class. And you saw this is a few seconds only, a very short command, and I can use htop, which is a resource monitoring and management tool for Linux. And you see I'm on my cloud server, 1 GB of working memory and 1 CPU core, no swap. So it's basically what I ordered, I've gotten here via F10. I can leave that, and I want to show you the installation of Python by Miniconda. This is my little demo here. So here you see that it redirects me to a certain instance here. And the right one for me is here, the one Linux Python 3.7 64-bit. And I copy the link address here. Going back, and I now retrieve this file here, which is 15 megabytes large. And I can get started by installing this Miniconda file. In order to proceed, now there is a little bit of a dialog. I press return, space, say yes, go with the default. And also here I go with the default, and it's already starting to install Python 3.7. This now is a process which might take a little bit. And we wait a little bit. It's not too long because it's just a base install for Python, and it's already there. I might now restart Bash and check Conda. Conda is there. This is what I wanted to have. And I can now do Conda install IPython, NumPy, no MKL to speed things up a little bit. No MKL is a meta package which prevents Conda from installing the MKL, Intel Math Kernel Library. It now communicates with the server, and I say yes, because I want to get this all installed, what I required. And it's not too long. Yeah, it's already finished. And now, when I increase the size a little bit, I can type IPython, and it says Python 3.7.1, IPython 7.2. I can do import NumPy as NP because I've installed NumPy. And I can do similar to what I've shown before. I can draw a bunch of random numbers now and print them out. And you have seen this now has taken some, let's say, 4 or 5 minutes to set up and update the cloud instance to install Miniconda to get IPython plus NumPy installed. And here I'm in the cloud on my cloud server running IPython and do the first steps with NumPy, for example, here to draw random numbers. So when you, for the first time, get into touch with these technologies, you might be a little bit afraid of these technologies and the things that you need to learn, the skills and know-how in order to go all these steps. But I think this little quick overview and demo has shown to get started, to get to the, let's say, the 80%, the typical ones, it's not that involved and everybody can master this. So don't be afraid of that. Just go with it. And I can now here say exit, and I do exit. Again, I exit here until I'm on Mac. I'm on Mac here again. So my connection is closed and I show you the whole process. Now I can go take this demo droplet and destroy it. And you see here the destroy button. I confirm to destroy the demo, and I am built for this whole procedure now only for 1 hour. So for like, I don't know, less than 1 cent for this whole procedure. For commissioning the droplet, for installing Python, for working on it a little bit, and now I have destroyed it. So this is a whole process. And you see, this is pretty straightforward when we use DigitalOcean for it. Quant platform, this is what we provide out of the box for you to study. You have basically everything available there to get started. But if you want to work with your own cloud-based infrastructure, we show you also everything that you require. The next example is a quick run through a interactive Jupyter Notebook. And this is based on the Icon API. Here I have an Icon Jupyter Notebook. In the back end, I have here the Icon proxy running. And this is from a video tutorial series that we have created for Refinitiv Icon, which has been recently made available to Icon subscribers. It's about a random walk hypothesis. Again, I don't want to get into details here. What you need in order to replicate what I'm doing here is indeed subscription to Icon. But all the other technologies like visualization and analysis that I implement there can be done with any financial data source, be it static one or via API. So I'm doing some imports, just showing here what versions I'm using there. And this is now the point where I connect to the API. I have stored my login credentials in a configuration file, also something we cover. Here I retrieve cross-asset data, GE, Apple, S&P 500, and a few more. So this now connects for the first time to the API, and I have retrieved my data set here. So this doesn't seem to be really complete. Let me maybe retry it. I don't know. Doesn't provide me with everything, but let me have a look at the data. Yeah, we can live with it. Maybe they're starting. There have been some data issues, and I only want to work with complete data rows there. So we end up with a complete data set. I can calculate the log returns, something you will see, I don't know, maybe 8-10 times during the course of the program at least. And we again get here one not a number row, but pandas is pretty flexible with not the number values. We can calculate the correlation matrix kind of easily here for our cross-asset data set. Now let us plot the data. I use a Plotly with cufflinks, and for example here the normalized data set, completely interactive presented. I can also zoom in or auto scale it once again now for the data we have retrieved. We can also plot the data as a histogram. Here it's now the returns data, which is often visualized as a histogram. Also, this is interactive here for our 7 assets. We can, and this is one of my favorite plots, also visualize the correlation matrix as a heat map. This comes out of the box here. You see, I simply say heat map, color scale blues, and it presents me with the heat map for the correlation matrix. Of course, every single instrument is perfectly correlated with itself. The darker the blue, the higher the correlation here. And yeah, all interactive, all making use of Plotly and cufflinks. Now we implement a little bit of an analysis to analyze the random walk hypothesis. And to this end, we create some lagged data, also explained in detail and repeated, I must almost say over and over because it's so important. Here lagged data based on prices, but usually we work here with returns as well. But for the random walk hypothesis, this is about prices. You see here the price column and 5 lags of the data. So this is going downwards, and we implement an ordinarily scarce regression. In the program, you will see how this is applied in similar fashion, but where we replace OLS regression by more sophisticated machine learning and deep learning algorithms. This is all covered, and we can have a closer look here at the data. I just want to focus on the visualization, and you see my prediction of the prices for the Apple stock. Here is more or less a right shift. This is the blue line of the orange one. In other words, we find some support here for the random walk hypothesis, but this is better illustrated here when we have a look at the regression results that I'm going to visualize here. Because for the regression, we see that the most previous lag is the most important one and has, in terms of explanation for a future value of my stock price. And the same holds true for the indices here, or for your euro-US dollar exchange rate, or for gold, or here even for the 10-year bond, which is our reference bond here in Germany. You see that basically only the most previous lag 1, is the one that explains future prices in an ordinarily scarce regression world. In other words, we find kind of strong support on a daily basis, on a daily data basis, for the random walk hypothesis, which can be formulated as saying the best predictor for tomorrow's price in the least square sense is today's price. And this is what we see visualized here. We can also take the mean over all regression parameters, and we see it even more pronounced, what I just pointed out. Basically, lag number 1 has almost all the weight. We can talk of some 100%, although this is not completely correct. And here we have basically all the other weights, which are pretty close to 0. So don't play a role in predicting the future price. So this can be interpreted as support for the random walk hypothesis. And when we think back a little bit to our major topic, namely algorithmic trading, this is what we are up against, that we find relatively strong support for the random walk or efficient market hypothesis. And if we want to come up with predictions with algorithmic trading strategies, this is what we face as our opponent. Because if markets are really efficient, if the random walk hypothesis holds true, then we might be having a pretty hard time in coming up with valuable algorithmic trading strategies that beat the odds here that we just see based on OLS regression. But that's the reason why we are trying to use nonlinear, more sophisticated algorithms as compared to ordinarily scarce regression. And that's also one of the reasons why we will mostly focus when we deploy our strategies on intraday strategies and not on end-of-day data and strategies. So here I'm retrieving 1-minute bar data. And the idea might be that once we repeat the analysis, we might see different results intraday. And indeed, quantitatively, we see different results, meaning that the most previous 1-minute bar is not as important as the most previous 1-day price for all the different instruments. So intraday, the world looks a little bit different, although qualitatively, we see still that the most recent observation, now it's 1-minute bar, here in our case is the most important one, but not as important as we have seen before with the end of day data. And here we see kind of the averages over all the regression results. Conclusions here from this little analysis. First of all, it's easy to retrieve historical end of day and intraday data across asset classes when you use some service like the Icon Data API. Plotly and cufflinks, I think, make for fantastic and convenient visualizations. And we can say that there is some support for the random walk hypothesis based on the OLS regression analysis, both daily and a little bit less so intraday. I have intentionally chosen this example because it sets a little bit the stage for our algorithmic trading efforts, and that we must face reality and say, well, not all theories in finance are well supported by empirical evidence, but unfortunately, maybe for us, the efficient market hypothesis and the random walk hypothesis are the ones that show kind of good support on the empirical side. This was the one little demo. I'm going to restart and clear this notebook and move on towards the next demo. And this is one about streaming data and visualization, one topic that I characterized as important. And it is one also that we typically will cover on the shell and not as much on or based on Jupyter Notebooks. And I go here on the shell, and maybe I show now all the different elements here. And what we get started with, let me open my, well, first I show you, I have here 3 Python files, tick client, tick plot, tick server. And I open here tick client. I didn't open my other one, so let me first open the tick server in a new tab. So this is Vim that I'm now using. We cover this also in some detail. And last but not least, I have a third one, tab tick plot, and these are the 3 files that I want to demo now. The tick server is the first one. This is how we simulate the real world market. This just spits out random data. Let me get started with the spitting out of random data. Here I can start this script via Python tick client.py, not client, server is the one that I need to start first. And immediately it spits out random data. So this is supposed to simulate here the Apple stock price, or to this end any other financial instrument, where we have 2 sources of uncertainty. The one is the time of arrival and the other one is the price itself. This is just our sandbox, how we simulate it. We as traders, as retail algo traders, as professional algo traders, as financial analysts, we retrieve this data. So we are on the receiving end. And this means that we are on the client side. And here I'm starting the client in the second window. And this retrieves from the server the data. It does a timestamping. And the code for that is as short as what we see here. So a few lines of code, and we can retrieve via socket communication what the socket publisher part here spits out in random fashion. Again, 2 sources of randomness. The first is the time-based one, where we say, well, we don't really know when the next observation comes, and also the price itself, which is modeled randomly. What we also cover in the program is the visualization. This is typically a little bit more involved, and here you see the script. More means that I make use here of a script that has 40 lines of code, including all the blank ones and the comments. So it's not that involved, it's not that huge, but still it's a few lines more. But the fantastic thing is that with 40 lines only, I must say, I'm able to plot the streaming data. So this script, which is called tick plot, retrieves the data and plots it in real time via a service. So it connects to the Plotly streaming service. You need to have an account for that. We explain all this in detail as well. So here I'm in my account with my username Eve. And immediately you see how my simulated Apple stock price is now plotted in real time. So when I open the shell here, I can resize my windows a little bit to accommodate it all. Basically, whenever a new data point is retrieved here, it collects the data point and sends it immediately to the streaming service so that we here actually see now the data streamed in real time. And streaming in real time means I can zoom in, I can zoom out, I can mark certain areas. So we have the flexibility of all the nice functions here with Plotly, but not only in the static fashion, but in the real-time streaming fashion as well. Some examples are provided where we also visualize in real time simple moving averages and so forth. So quite a bunch of examples based on a wrapper package that we have come up with that you can make easy use of. But streaming visualization used to be pretty involved, but here you see with a few lines of code, and if you use our wrapper packages, even fewer lines of code, you are able to visualize your data in real time. So this can keep on running. It doesn't really hurt, but I'm going to close now these tabs that I don't need anymore. This is with regard to streaming data and visualization. Now, the two last examples, the one is about Python, Pandas, and Excel. And to this end, I'm going to open the second notebook here. This is just a really quick run through Python for Excel. To this end, I'm going to open Excel first. So I open Excel, not a certain sheet or what. Here you see there is Excel now. I could now get started with an empty sheet. I just wanted to start Excel in the back end. In Python for Excel, we mostly make use of Excel Wings. This is the primary package, and it is as simple and as straightforward as follows. First example is, how do I write data to an Excel spreadsheet? First, I need an Excel spreadsheet. This is done here by WB. We assign a new object, xw.book. So you see something blinking. In the back end, when I get back to Excel, I have suddenly a workbook open. This hasn't been open before. It's not yet saved. It's simply a new empty notebook. So I change now between the notebook here and my Jupyter notebook. So I connect to the active sheet and I write, for example, a text, "Hi from Python." And when I do this, here we don't see a thing, but when I get back to my Excel spreadsheet, you see, oh, in the upper left-hand corner, it says, "Hi from Python." So I have written some text from Python to my Excel spreadsheet. The next here assigns a few numbers to another place, A3. No feedback here. This is a good sign in general. And here suddenly there appear numbers 0 to 7. Numbers that we have gotten. So this is one way, so to say. Getting back, the other way is that we can read data from Excel. Sheet range A1 value gives me "Hi from Python." I read out this particular cell. And via this command, adding the method expand, I can read also a bunch of numbers into a list object. Also, this works pretty well. These are, of course, meant to be simple introductory examples. Let me now move on towards a typical data set that we use. I retrieve this from a remote resource. This is now financial data with some 2,138 rows, a bunch of instruments. In there, I add a new sheet. So this is now in my workbook, book 1, sheet number 2. Quick check. Oh, I suddenly have a sheet number 2. This is sheet number 1. Sheet number 2, this was added from Python. Maybe I increase the zoom a little bit. And I write now the resampled data to this sheet. So you see, this is in real time. I have written now the monthly data. I did the resampling on Python, and it writes all the numbers, headers, index values to Excel. Of course, on the Excel level, I can do any kind of formatting that I want to do. Maybe I do change the color here. Maybe I make this fat. So on this level, you can now work with Excel as you're used to. But the data has come from a remote resource. I've used pandas and I've written the financial data to Excel. The final example in this section is to get the data back. This works the same way. I need to use a few options here. I say, when you read the data, please give me back the data as data frame. And I can also read data from this table into a data frame directly. This is now the monthly data, which I have read from the Excel spreadsheet. The final example overall here in this little demo is to create a plot and to put a plot into an Excel spreadsheet. I open a new sheet, quick check, yeah, sheet number 3. My active sheet now is number 3. I create a normalized plot here of data, the time series data, and I add the picture, and let me check on Excel. And like magic, my bitmap appears. This is, of course, not an editable Excel plot, so I cannot double click here. I mean, I can, but I cannot edit it. I have just a few elements here, like formatting the picture, but it is a bitmap. It's not an interactive plot, so to say. I can, however, here change the size, change the position. I can also, from Python and Excel Wings, from the outset, define a position and the size. But more on this in the Python for Excel class. This is just a quick run through how easy and straightforward it is to do some work when you're in the Python environment and interact with Excel. I'm closing this. I'm not saving it. I don't need it. And I'm finished here with my analysis. So I might restart and clear the output. And save it again. Finished with Excel. Quick look. Very last example here, number 6. We are seeing quite a few already, is about the Wanda trading platform. Again, meant to be a teaser. We work intensively with Wanda, also with the other trading platforms. Basically, from now on, we will make use of a little Python wrapper package that we have come up with. It's supposed to simplify things quite a bit. And here, a quick run through. You are supposed to have a account, a demo account with access, and we explain how to store the credentials. You see here, this is in my credential file. With TPQ-OA, I just provide the credentials file, and for example, I can now access here what instruments are available on the platform. Here, instrument euro, US dollar. I say, for example, get history for my desired instrument, which is the euro US dollar pair. And I get, for this one day, I get 1,429 observations. I'm formulating a simple strategy here, a time series momentum one, also something explained in detail during the program, and come up with a few new columns. The hit ratio is calculated. You see here false, true, true. So every false is not what I would like to see. I would like to see more trues. But the strategy here with this number is not the best one. We just have a hit ratio of 47%, but we need to check the economic performance. Hit ratio is just one influencing factor. And we see here already when we visualize this that the green line, this is now vectorized backtesting, shows a kind of decent outperformance compared to the underlying itself. So over this day, when we do the backtesting, there seems to be something attached to the strategy. So we have retrieved data from Wanda, and here we can now also plot the strategy. You see the green line now represents the position. If it is +1, it is a long position. If it is -1, it is a short position. So this momentum-based strategy, indeed, yeah, it has quite a high turnover. It places lots of trades, so to say, and transaction costs are typically a major influencing factor. So just to close this out, here I have my Yonder account open. There is no open trade, just to show how straightforward it should be to create a new order. So here I'm placing an order. And when I now have a look at my Wonder account, is this kind of current? Maybe I'm connected to another one. I'm not sure because I have that many Wonder accounts. It's now loading the data. Here we go. So you see that my 100 units that I've placed euro US dollar are now in my account. So in real time, when this is all up and running, I can see and place trades. So here is the data that is delivered back. And when I place an order with minus 100 units, I should close out this transaction. You see here, I close out the transaction. When I now have a look at the Wonder account, you see that the trade has already vanished. So it's kind of straightforward in general, and with our wrapper package TPQA in particular, you see to create orders, long, short positions, and for example also to print the most recent transactions. Maybe I go here with I don't know, a higher number for what I do, and I see the most previous transactions here, euro US dollar. These are the two that I have just placed. This is GMT time that we get here. So we are 1 hour ahead in Western Europe, in Germany. And this was my plus 100 trade, no P&L. And this is the minus 100 trade. Here I closed out the position and we made a tiny loss here already due to the bid-ask spread. So you see this works in real time, and most of the operations are single line only. Again, just to whet your appetite. Many more details during the program, and in particular with regard to Wonder, we use it throughout as one of the major platforms we work with. So let me clear out. Start. So I can change that one and save it. So that we have now gone through the case studies and demos. I showed you how to access resources on the Quant platform. I showed you how to install Python, IPython, and NumPy in the cloud. We did a little bit of financial analytics with Icon Plotly with regard to random walks, both end of day based as well as intraday. I showed you how to work with streaming data, at least rather quickly. I showed you that. Then we visited Excel Wings, which combines the Python world, I think, kind of seamlessly with the Excel world. And last but not least, I've shown you the Yonder trading platform, at least the very first steps, retrieving historical data, 1 minute bar, doing a little bit of backtesting. And I also showed you quickly how to place orders and how to inspect these on the Yonder interface, as well as via the historical transactions. My final section here about the importance of practice is only based on a few quotes that I find so important. Now that you should have gotten a good overview, an introduction into the program, and a feel for what to expect there. Here it's from a book I really recommend regularly by Anders Ericsson from 2016. He's one of the best known researchers in the field of peak performance. He has studied musicians, chess players, and quite a few others in this regard. And he said, well, when you have a look at how people are trained in the professional and business worlds, you find a tendency to focus on knowledge at the expense of skills. So this is like reading a book about driving or reading a book about swimming, but never jump on a car, nor never jump in the pool. So we are mostly dealing with skills and not that much with like knowledge. So there won't be multiple choice tests, for example, with regard to what parameters can be used with the plot method of the data frame. It's rather that you know how to use the plot method, where to look up the documentation and the parameters, because our ecosystem is pretty much too large to recognize everything. It's rather to know and to learn how to look up things and how to apply them. And here he says, I believe the best approach will be to develop skill-based training programs. And this is what we had in mind, that we equip you with the skills and not only with some knowledge about something. Therefore, our training should focus on doing rather than on knowing, and the proof lies in doing it, as they say. Also here from the book, no matter which area you study, music, dance, sports, competitive games, or anything else with objective measures of performance, you find that the top performers have devoted a tremendous amount of time to developing their ability. So if you come across somebody who is well skilled in the areas that we cover, it is almost with certainty, due to the fact that this particular person has spent many, many hours of mastering the skills required for the particular topic. So as they say, there is generally no natural talent. And this is more like, for me, it's kind of like, when I think of it, I can make peace maybe with the fact that others are much, much better in certain areas than I am, because I know, well, probably have spent more time on a particular or on the acquisition of a particular skill that I have. But that in general, it's also true that there is no innate talent, as they say. So be aware of the fact that you need to put in the time to master it until you can compare yourself maybe with the more advanced people or even the pros in a certain field. And last but not least, I want to let one of our previous delegates come to word. And this is what really lets my heart beat faster, because this is what we would like to hear. This is, let's say, like an ideal scenario for us, where Elvis pointed out, he's a student from last year, where he said, well, I like watching your videos, but it's much more interesting and educational to actually build something on my own. Even when I bumped into issues, I was able to fairly quickly find the solution, which is testament to the quality of the available documentation for the technologies that we are using. Again, I think this is related to skills, and you should watch out that you focus on the skills in particular that you try to acquire, and not as much on remembering, internalizing certain details about certain methods, functions, packages, and so forth. It's more about the skills, how to apply things, how to look up things. And then I think you're on a pretty good way to master one day Python for algorithmic trading, to come up with fantastic, well-performing strategies and to deploy them in automated fashion. Having said that, I wish you all a pretty good start with our program. Please make heavy use of the user forum for any technical questions. We are also doing, usually on a more irregular basis, Q&A sessions where you can ask your personal questions, and we can go into details where we might have skipped over a little bit too fast here and there. And feel free to reach out with your organizational questions by email. So you have lots of resources, you have multiple venues to reach out and to get feedback. And I'm pretty sure that after a little while, you will get accustomed to Python. And in that sense, I wish you going forward happy Python coding and algorithmic trading. I'm excited to accompany you on your way over the next 16 weeks and even maybe a little bit longer. And in that sense, take care. Bye-bye. See you in the next session.